Welcome back to Barnes Basics, and we're going to do the third step to this decomposition problem, and we're going to find out how many grams of oxygen are prepared in this problem. The problem was earlier stated and it's restated now. A mass of 25.0 grams of mercury 2 oxide is decomposed by heating. The reaction is 2 moles of mercury oxide yield 2 moles of mercury plus 1 mole of oxygen gas. So remember, the first step in any of these problems is to write the balanced equation. That's already done for you, and that's a beautiful thing. 2 mercuries, 2 mercuries, 2 oxygens, 2 oxygens. Everything's good to go. The second step is to write the information that we are given on the left. In this case, we're given 25.0 grams of mercury oxide. And we're asked to find grams of oxygen. That's what we're being asked to find, grams of O2. This gets a little bit more difficult in this problem because this is a multi-step problem. But that's okay. People like us, we can handle this. We can get bossy with this and do it. We are going from grams of mercury oxide to grams of oxygen. And so the first thing that we're going to do is we're going to try to convert from grams of mercury oxide to moles of mercury oxide. Then we're going to use a mole ratio right here. And then we're going to go from moles to grams of oxygen. And so this is kind of a bridge that we're going to walk across right here. Now, we earlier found that 1 mole of mercury oxide is the same thing as 216.58 grams of mercury oxide. We know that. Okay, I'm kind of getting crunched right here. Let's spread this out just a little bit. So grams of mercury oxide and grams of mercury oxide cancel like this. How did we know that? Because when we look at mercury oxide, or moles, that's a better way to say it. 1 mole of mercury is 200.59 grams. 1 mole of oxygen is 15.99. I figured that out. I looked at the periodic chart. I added these two together with my TI-83. 200.59 plus 15.99 is 216.58 grams per mole. Now, if we're going to oxygen, in the balanced equation, we have to have oxygen on the top right here. So we see that there's 1 mole of oxygen produced for every 2 moles of mercury oxide used. So we would put 1 mole of oxygen on the top, and we would put 2 moles of mercury oxide on the bottom. And that way, mercury oxide cancels. Now the last thing that we have to do is go from moles of oxygen to grams of oxygen. And this is actually kind of simple. When we look at oxygen, or diatomic oxygen has 2 moles of oxygen in it. And each one weighs 15.99. So to find out how much 1 mole of oxygen O2 diatomic weighs, we would just multiply 2 times 15.99. I got the 15.99 off of the periodic chart. So in our TI-83, on, clear, 2 multiplied by 15.99, enter. I get 31.98 grams per mole. So in our formula over here, we're going to say that we have 31.98 grams in 1 mole of O2. That allows these units to cancel, and you can see that grams of O2 is what we are wanting in our final answer. So let's plug this information into our calculator and roll with it. Remember, we're going to divide by the things on the bottom one at a time and hit enter after every time. Let's place this in our calculators. Remember that we multiply by what's on the top and we divide by what's on the bottom. Remember, after every division, hit enter every time. And so let's see what we can do with this. 25.0 multiplied by 1 multiplied by 1 multiplied by 31.98 and hit enter, and I got 799.5 divided by 216.58, hit enter, and I got 3.69 divided by 2, hit enter, and I got 1.845. Now remember, 25.0 has 3 sig figs, so if we get 1.845, we might say that the 5 rounds this 4 up to a 5. That might work. So let's report it as 1.85 grams of oxygen that are prepared when 25 grams of mercury oxide are decomposed. Very good. Kind of complicated. Just remember that when you put this, as far as the order of operations goes, remember to multiply by what's on the top, enter, and then divide by the first number on the bottom, hit enter, divide by the second number on the bottom, hit enter. The one thing that I didn't do is estimate for my answer. And by the way, step 3 was show the mole proportions, and then step 4 was determine the mass of the moles of each substance. So we did all of the steps. The only thing I didn't do is estimate the answer. I've never been very good at that. That's a good thing if you can do it, and sometimes I think about it. In this case, I did not, but that is the correct answer. 1.85 grams of oxygen produced for 25 grams decomposed of mercury oxide. Very good. Marvelous.